The topic of this video will be the acid-catalyzed hydration of alkenes. In the acid-catalyzed hydration of alkenes, we're adding a molecule of water across the double bond. This process requires an acid catalyst and oftentimes heat. The product of this reaction is an alcohol. Notice that this process is the reverse of the dehydration of alcohols that we previously talked about. In order to control the direction of the equilibrium, we need to use Le Chatelier's principle. Increasing the concentration of water will push the equilibrium towards the alcohol product. Removal of water will push the equilibrium towards the alkene product. Now let's look at the mechanism for this process. This mechanism is the reverse of the E1 mechanism. In the first step, the alkene is protonated to form the carbocation. In the next step, the nucleophile, water, attacks the carbocation to form the protonated alcohol. In the last step, another molecule of water removes the proton from the alcohol to produce the neutral product. Now let's look at a specific example of the acid-catalyzed hydration of an alkene. The acid-catalyzed hydration of an alkene follows Markovnikov's rule. We get the Markovnikov product as the major product. We do not get the less substituted alcohol product. Again, this makes more sense when we look at the mechanism for this reaction. In the first step of the mechanism, we protonate the double bond to produce the carbocation intermediate. Depending on which carbon the proton adds to, we get two different potential carbocations. If the proton adds to the more substituted carbon of the double bond, we get the secondary carbocation. If the proton adds to the less substituted carbon of the double bond, we get the tertiary carbocation. Like always, the tertiary carbocation is more stable and forms more quickly and results in the major product. In the next step, water adds to the carbocation. This produces the protonated alcohol product. In the last step, another molecule of water deprotonates the alcohol, producing the major Markovnikov product. Remember that because this mechanism passes through the carbocation intermediate, there is always the potential for a carbocation rearrangement if a more stable carbocation can be formed.